Sample problem 24.03. What is the electric potential at point P located at the center of the square of charged particle as shown in the figure? The distance d is 1.3 meter and the charges are q1 equal to 12 nanocoulomb, q2 which is equal to minus 24 nanocoulomb, q3 which is equal to 31 nanocoulomb and q4 which is equal to 70 nanocoulomb. So in this question, we have to find what is the electric potential at point P. And also they clearly mention all these four particles will form like a square structure. Clear? So in square, all sides are equal. So we have to find what is the potential at point P. As we know, the potential calculation is given by the rule V, which is equal to K Q over R. So the R is very important for this question because K value is a constant, Q is mentioned here. So I have to apply this rule for all these charges. But the most important thing, finding the value of R. What is the R? So here you can see this diagram. In square, all sides are equal and the diagonals are equal. So if you see the diagonal, so the diagonal will be passing through this point P. So in this square, we have two right angle triangle. You can consider any one of the triangle. So for finding the value of R, I'm going to choose any one of the triangle. So let's we just name this triangle as A, B, and C. So in triangle ABC, we are going to apply the Pythagoras theorem. So therefore, AC square, which is equal to AB square plus BC square. And here AC is nothing but here the diagonal. So I'm going to apply the value for AB as well as BC. So AB as well as BC takes the value of D. So therefore D square plus D square, which is 2D square. So this is AC square. So if you find the value of AC, we will get, I have to take the square root on both sides. Therefore AC, which is equal to D root 2. So what is this AC? Here AC is the diagonal. And if you want to find the distance of the charge to the point P, so let's see here. If you consider this is the diagonal, the half of the distance here is nothing but R for each charges. So let's see. So this is the another diagonal here. So let's see the distance from charge Q1. The distance of charge Q1 to point P is R. That means here half of the diagonal is the value of R. So if you see the remaining charges, it will also give the same answer for Q2. What is the distance from the charge Q2 to point P? So this is R. So again, this is the diagonal. So that means for finding the value of for R for all the four charges, it's very easy. Therefore, R, which is equal to the diagonal divided by 2, which is nothing but AC divided by 2. So I have to divide this number by 2. So 2 root 2 over 2. So how we can write the 2? We can write 2 like this, right? So we can cancel a root 2 with this root 2. So finally, the R value here is D over root 2. Clear? Now it's very easy. We are going to apply the value of the apply the formula for all the four charges. By that we will get the net electric field at point P. So therefore the net potential which is equal to K Q1 over R plus K Q2 over R plus K Q3 over R plus K Q4 over R. Now we have to see the value of the charges. So here Q1, Q3 and Q4 are positive, but Q2 is negative. So we have to consider the sign for Q2 is negative. So here what we have to do, we are going to write this equation. So here in place of positive, what we have to do, we have to put negative. Why? Because the Q2 is negative. So once you substitute the values, let's take the common term outside. So here the common term or K over R is the common term. So let's take outside. So what is inside? Q1 minus Q2 plus Q3 plus Q4. So now let's we substitute the value of Q1, Q2, Q3 and Q4. So here the value of Q1, Q2, Q3, Q4 is given. So Q1 12, this is 24, 31 and 17. 12, 24, K over R, 12 nanocoulomb, nano stands for 10 to the power of minus 9, minus 24 multiply 10 to the power of minus 9 plus Q3 value is 31 and 17, right? 31 nanocoulomb and then 17 nanocoulomb. Now let's we substitute the value of R, because R value we find here as D over root 2. So if you just substitute the value of D over 2, because R which is equal to D over root 2 we found in the previous part. So if you substitute the value here, root 2 K over D will come, because when you substitute this root 2 will come to the top. So what is remaining? So 12 minus 24. So let's we substitute the 12 minus 24 plus 31 plus 17. Here for charges we got 36 nanocoulomb. So 36 nano 10 to the power of minus 9. And let's we substitute the value of D as well as the K. So root 2 multiplied by 8.99 multiply 10 to the power of 9 over D. What is the value of D which is given in the question? The value of D is 1.3 meter. So I have to substitute 1.3 in place of D. So 1.3 multiplied by 36 multiplied 10 to the power of minus 9. So let's see what is the net potential at point P. So here root 2 multiply with 8.99 10 to the power of 9 multiply 36 10 to the power of minus 9 over 1.3. So the answer for net potential is 352.07 volt. So this is the answer for this question. That's it. Thank you.